If you're an English nerd, you might enjoy this one. Which verb completes the sentence, is or are? The sentence takes is. Report is the main subject. Managers is plural, but it sits inside a clause describing report. GPT-2 still picks are. I put all of the experiment code on my GitHub so you can run it yourself. In order to fix this, I copied one attention head output from a version of the sentence the model handled correctly. I replaced one activation at the final token position without retraining or updating the weights. The patch flipped the answer to is. I had changed one activation in one sentence. In April 2025, OpenAI faced a much larger version of this problem. An update had changed GPT-4o's behavior across many conversations, so they rolled it back. GPT-4o had become noticeably more agreeable and flattering. OpenAI described the behavior as sycophancy. The report says short-term feedback had too much influence. GPT-4o shifted toward responses that were supportive but disingenuous. OpenAI rolled back the update, changed training and system prompts, and expanded its evaluations. I wanted to know which internal computations carried a change in behavior. Mechanistic interpretability gives us experiments for narrowing that question. I went back to GPT-2 and a prompt small enough to inspect directly. To understand how that repair could work, I started with 5 words. The cat sat on the. This smaller prompt gives us room to learn the parts of the model before returning to the grammar failure. GPT-2 turns each token into a vector and passes those vectors through 12 repeated blocks. Inside each block, attention retrieves information from other token positions. The MLP transforms the information stored at each position. Both write updates into the residual stream, the running state passed to the next block. GPT-2 splits attention into 12 heads. Each head can retrieve a different mixture of information, and their outputs are combined before being added to the residual stream. We now have names for the places where we can inspect the computation and change it. Mechanistic interpretability studies how those internal paths produce a particular behavior. We inspect the states and components between the prompt and GPT-2's next token prediction. The workflow resembles debugging. Observe where 2 runs begin to differ. Form a hypothesis about the component carrying that difference, then change that component and run the model again. The experiments use probes to locate candidate mechanisms and interventions to test them. We'll define each technique before using it. Matched prompts differ by one control feature, so we can track where their internal states separate. Attention weights show which earlier token positions a head reads from. GPT-2 converts the residual state after its last block into vocabulary scores using its final normalization and vocabulary projection. A logit lens applies that same conversion to the residual state after an earlier block. The resulting token scores are the logit lens readout for that layer. These observations tell us where to intervene next. I tested those candidates by changing the model and running it again. In source ablation, we mask one earlier token as an attention source. In head ablation, we replace one head's output with 0. Scaling turns that same output down or up. If the model changes with the intervention, it depended on the information or component we changed. After an intervention, I followed where its effect went or tried to repair the failed run. Downstream tracing records how the changed activation moves through later attention and MLP blocks. Activation patching takes one activation from a successful run and inserts it into a failed run. If that replacement changes the answer, the patched activation had a causal effect in that run. These tools let us find candidates, test them, follow their effects, and try a repair. Now that we have a feel for them, let's use them on a simple prompt. I first ran 2 complete prompts. The cat sat on the mat, then the dog sat on the mat. One token changed. Attention patterns and hidden representations changed throughout the network. To compare 2 full token distributions, I used total variation distance. 0 means the distributions are identical. 1 means they do not overlap. You can read it as how much probability mass moved between tokens. In this comparison, the largest attention pattern change appeared in 0-indexed layer 6, head 4. That gave me a location to test. The next step was to change that head and measure what happened to the output. I shortened the prompts again and inspected the final token's residual vector after every block. A residual vector is the model's running representation at one token position. Each block reads it, adds information, and passes the updated vector forward. I applied that readout after each block and recorded the resulting token scores. The logit lens bars show the highest scoring vocabulary tokens at each layer. Early on, both prompts mostly exposed the word same. Through the middle blocks, the cat and dog runs pulled apart as information about the changed noun reached the final token. Near the end, the shared phrase sat on the narrowed both runs towards surface and location words. They both finished with floor on top, though the rest of the rankings still differed. These bars are probe readouts from each layer. GPT-2 makes its next token prediction after the final layer. The projection showed where the states differed. To test dependence, I chose one earlier word at a time and used it as a source mask. The word and its position stayed in the prompt, but its key and value were unavailable to later tokens. In the attention matrix, that means masking chosen source column for every later query. I applied the same mask to all 12 attention heads in every layer. SUT produced the largest change. Floor, the original top candidate, nearly disappeared. Left became the new top candidate. GPT-2 depended heavily on attention access to SAT for this prompt. Because the mask covered every head and every layer, this was a broad artificial intervention. This showed that the model used information from SAT, but not which heads or layers used it. The readout changed sharply around layer 7. Before this block, same still dominated. After it, surface and location words took over, so I opened the block to see where that change happened. Layer 7 is the 8th block because the code counts from 0. Attention reads across positions and adds an update. Then the MLP transforms each position and adds another. Before attention, same dominated the readout. After attention, shoulders moved to the top. Attention had pushed the representation toward a continuation that used more of the sentence's context. After the MLP, floor led instead. Edge, table, and ground also became prominent. The narrow shoulders direction had become a broader set of surface and location directions. Layer 7, attention contains 12 heads. I removed them one at a time by replacing one head's 6-4 NUMBER output with zeros before the heads were mixed together. Head 8 produced the largest immediate change in the logit lens distribution. Removing head 8 cut the readable shoulders signal by more than half. The final distribution moved much less. Another head even had a slightly larger final effect, which was an early sign that the computation was spread across components. I turned head 8 into a strength knob. As I increased it from 0 to double strength, the shoulder signal climbed smoothly and almost perfectly. The final answer barely moved, and flow stayed on top throughout. Head 8 gave me a strong internal control knob and a weak behavioral one. I compared the amplified HEAD run with the normal run. Right after attention, the difference between their final token states pointed strongly toward shoulders. The layer 7 MLP changed the direction of that difference. The two states were still far apart, but much less of the difference lined up with shoulders. The next MLP pushed it farther away. The shoulders readout shrank as the MLP redirected the change into other directions. I next tested which neurons inside the layer 7 MLP helped produce that turn. The layer 7 MLP contains 3072 neurons. I used gradient scores to rank which neurons were most connected to the turn from shoulders toward floor and ground. That gave me candidates to test directly. I tested those candidates by removing their contribution one at a time. In the normal run, I set one neuron to 0. In the amplified run, I replaced its changed activation with the value from the normal run. I zeroed neuron 1766 and ran the model again. Immediately after the MLP, shoulders became more readable while floor and ground weakened. This neuron helps push the state away from shoulders and towards surface words. Most of that difference disappeared in later layers. Other neurons pushed the same way, and another group pushed back. Neuron 1766 contributes to the turn, but the NLP produces it through several neurons together. By now, I had followed a change from the whole model into one layer, one attention head, and individual MLP neurons. I had learned how to keep narrowing the question. I wanted to use that process on something the model clearly got wrong. Then I could trace the error inward and test whether replacing one internal activation would fix the answer. For that, I needed a repeatable mistake with a clear, correct answer. I chose subject-verb agreement and asked GPT-2 to choose between is and are. I started with the keys to the cabinet. Keys is plural, so the answer is are. Cabinet is singular and closer to the blank, which gives the model a plausible distraction. It still got every one of these simple cases right. So I added one relative clause inside another. Now the model had to keep track of the main subject across a deeper sentence that produced 5 failures, and 4 of them had the same nested structure. The clean control was the report that the manager who the editor admired reviewed. The main subject is report, so the correct continuation is. GPT-2 agreed with high confidence. I changed the two embedded nouns to plural. The report that the managers who the editors admired reviewed. The main subject stayed singular. GPT-2 now preferred are, giving is only 15% of the forced choice probability. Two nouns had changed, so I could not claim that either one caused the failure. I needed to vary them independently. I made 4 aligned prompts. In SS, both embedded nouns were singular. In PS, only managers was plural. In SP, only editors was plural. In PP, both were plural. Report remained singular in every prompt. Changing manager to managers was enough to flip the prediction. Changing only editor to editors weakened the correct answer but did not flip it. Most of the damage came from the first plural noun. The second added a smaller penalty. The two penalties mostly added together without a new effect appearing when both nouns were plural. The useful repair target was now the PS prompt because it differed from the successful SS prompt at one token position. I traced all 4 conditions before attention, after attention, and after the MLP in every block. To measure the first noun, I compared manager with managers once when the second noun was editor and again when it was editors. Then averaged the two comparisons. That penalty built up across the network instead of appearing at one clean boundary. The largest single harmful transition was layer 7 attention. The penalty kept growing through later blocks and reached its strongest point after the layer 10 MLP. Layer 11 attention repaired a large part of the damage, though the final prediction still failed. The trace gave me a place to intervene to 12 attention heads inside layer 7. For each layer 7 head, I captured its output from the successful SS prompt. Then I ran the failed PS prompt and replaced one failed head output with the clean one. The rest of the failed computation continued unchanged. 11 individual heads left the model on R. Head 8, the strong shoulders head from the earlier prompt, helped a little but could not repair the answer. Head 4 was the only individual patch that crossed the decision boundary. The repair was strongest immediately after layer 7 attention. The MLP and later layers weakened it, but enough survived to cross 0 at the final output. GPT-2 now preferred is. I began at the scale of the whole model, comparing how one change token altered the prediction across layers. Layer 7 gave me a place to look more closely. Inside that layer, I tested attention heads, traced an MLP transformation, and intervened on individual neurons. The grammar failure took the same process from a wrong answer to one head output that could repair it. Each step narrowed the question from the model to a layer, to a component, and then to one activation. I could inspect a signal, perturb it, follow what changed, and check whether the final behavior moved. On this prompt, replacing one head output changed GPT-2's answer from R to is. That is the result I can defend. I can use the same process on another behavior and see which explanations survive intervention. Finding one mechanism starts a longer test. I would repeat the intervention across paraphrases, topics, and model checkpoints, then measure the side effects. If the result holds, it can inform a monitor, a steering intervention, a training change, or a new evaluation. Each option still has to survive red teaming and capability checks. Labs are already testing pieces of this workflow. Anthropic has traced circuits involved in hallucination and used probes to detect sleeper agent behavior. OpenAI has reported internal directions associated with misaligned behavior. Those results do not make a model safe by themselves. Steering one feature can change unrelated behavior or damage capabilities, so the intervention needs the same scrutiny as the mechanism. For me, the practical value is that a model failure becomes a sequence of smaller experiments I can run. The code for every experiment is on my GitHub. Check it out, and if you want to see the next one, subscribe.